7-1, 0 and negative exponents. So our objective for this section is to simplify expressions involving 0 and negative exponents. Our essential understanding is that we can extend the idea of exponents to include 0 and negative exponents. And what that means is we are going to think about how exponents work. So if we consider 3 to the third, 3 to the second, and 3 to the first. Well, first let's think about what that means. 3 to the third power means 3 times 3 times 3, which is 27, right? Raising something to an exponent means repeated multiplication. Okay, so, whoops, not 2. 3 to the second power means 3 times 3, which is 9. And 3 to the first power means just 1 3, which is just 3. And if we look at how we're getting from one of these numbers to the next number, when we decrease the exponent by 1, it's the same as dividing by 3 because we're multiplying by 1 less 3. So that means if we continue this pattern to go down in exponents, we're dividing these answers by 3. When we have 3 to the 0 power, 3 divided by 3, that's going to be 1. And when I have 3, what's 1 less than 0? 3 to the negative 1 power, that is going to be 1/3. That's interesting, okay? So when we have negative exponents, we can see that they don't give us negative numbers, has nothing to do with negative numbers. What it does is it gives us a fraction, okay? So let's extend that to a rule, and we have our properties of 0 and negative exponents. So for 0 as an exponent, every non-zero number a, if we raise it to the 0 power, we get 1, no matter what number it is. It could be 4. We could raise a negative number to the 0 power. We could raise a decimal to the 0 power, a fraction to a 0 power. Anything to a 0 power is 1, unless is 0. We'll talk about that in a second. Okay. So if for every non-zero number, if you raise it to a 0 power, you will get 1. Negative exponents. For every non-zero number a, an integer n, a to the negative n power, is equal to 1 over a to the positive n power. So basically what we're doing with negative exponents is we're making fractions. So 7 to the negative 3 power turns into 1 over 7 to the positive 3 power. So we change the exponents from negative to positive in order to evaluate them. And the way we do that is we move it from the numerator to the denominator, or vice versa, from the denominator to the numerator. And that changes the sign of the exponent. It does not change the sign of the number, still negative 5, except now it's raised to a positive 2 when you move it to the denominator of a fraction. Okay. Now, notice that both of these say non-zero numbers, which is important. Why can't we use 0 as the base with exponents? So the first property on the previous page implies the following pattern. So if you raise 3 to the 0 power, you'd get 1. 2 to the 0 power, you get 1. 1 to the 0 power, you get 1, which means that anything to the 0 power gets 1, except for that is kind of weird. So we can't really say anything to the 0 power is 1, because 0 to the third power is 0, because 0 times 0 times 0 is 0. 0 squared is 0. 0 to the first power is 0. So that means that 0 to the 0 power is probably also 0. So this cannot happen, right? You cannot have two things equaling different numbers. So it's not possible for 0 to the 0 power to be both 1 and 0. So 0 to the 0 power is undefined. And why can't you use 0 as a base with a negative exponent? Because if we had that, we would then say 0 to the positive 2, which is 1 over 0, which is undefined. So using 0 as a base with a negative exponent will result in division by 0, which is undefined. Okay, so going back real quick, both of these rules only work as long as the base is not 0. Okay. Let's see some problems with these. Okay, so what is the simplified form of each expression? So if I see a negative exponent, I change it to a fraction. So this becomes 1 over 9 squared. Now I can evaluate 9 squared, which is 9 times 9, which is 81. And for part B, anything to the 0 power is 1. Okay, let's try some more with our got-it problems. So what's the simplified form of each expression? This becomes 1 over 4 to the third power, which is 4 times 4 times 4 is 64. Negative 5 to the 0 power is 1. This becomes 1 over 3 squared, which is 1 over 9. This is 1 over 6 to the first power, which is just 1 over 6. And be careful with part E. This is 1 over negative 4 to the positive second power. By moving the term to the denominator of the fraction, you make the exponent positive, but it has nothing to do with the actual term. So negative 4 times negative 4, well, look at that. That makes it positive, okay? Which is when you square a negative number, it turns into a positive number. So just be careful with when you're moving things around and negative signs, okay? Now, an algebraic expression in the simplest is in simplest form when powers with a variable base are written only with positive exponents. And as we go forward in this chapter, we're going to be simplifying a lot of expressions that have exponents in them. This is the first thing we look for. Only positive exponents. So if we see a negative exponent, we have to do something about it. Okay, here's an expression. Notice that what is the simplified form of each expression? So we're going to simplify both of these expressions. In the first one, in part A, only the b is raised to the negative second power. This question would be much different if it looked like that. That's something we're going to see in a later section. But for now, only the b is raised to the negative second power. That means it's only the b that you are going to move to the denominator of a fraction. So the 5 is raised to the first power. Leave that alone. A is raised to the third power. And then b turns into 1 over b squared. Now I can put those together because technically I could think of this as a fraction too, all over 1. To multiply two fractions, multiply across the top, multiply across the bottom, and we get 5a to the third over b squared. Okay. For part B, notice we have a negative exponent in the denominator. Okay. So the simple way is to just move it to the numerator. The reason why this works is when we have a fraction like that, that's the same thing as saying 1 divided by x to the negative fifth power, okay? Which is the same as saying 1 divided by 1 over x to the positive fifth power. And to multiply something by, or sorry, to divide something by a fraction, you multiply it by its reciprocal, okay? Which then just turns into x to the fifth. Now that's the long way to go about it. Basically what I like to do is just see this 1 over x to the negative fifth power and just say, okay, we have a negative exponent in the bottom of a fraction, it becomes positive when I move it to the top. So this comes up and it turns into x to the positive fifth. Let's try some got it problems. Simplified form of each expression. X to the negative ninth power. Well, move it to the bottom and make the exponent positive. 1 over n to the negative 3. Move this up, and that makes the exponent positive. I don't have to put over 1, right? My denominator, if it has nothing in it, it just means over 1. The only thing in number C, the only thing that's raised to a negative power is the C. So the 4 stays up top, the B stays up top, the C goes to the bottom, the exponent changes to a positive. The act of moving the variable from the numerator to the denominator is what makes the exponent change from negative to positive. In part D, again, the only thing that's raised to a negative exponent is the a. It's in the bottom, so move it to the top, and the a becomes positive, or the exponent becomes positive. And in part E, n to the negative fifth goes down to the bottom. So on the bottom we have m squared, n to the fifth. If there's nothing left over on the top, we need a 1. Okay, don't put a 0. That means something different. That just means 0. Okay, if everything moves to the denominator of a fraction, there's a 1 left over on the top. Okay. When we evaluate an exponential expression, you can simplify the expression before substituting the values for the variables. This usually makes it easier. Simplify the expression first and then plug some stuff in. So what is the value of 3s t to the negative 2 for s is equal to 2 and t is equal to negative 3? Now I don't have to do this. I could plug these numbers in right away. But especially this one, plugging a negative number into a negative exponent can be kind of confusing. So before we do that, let's simplify this method. Let's simplify this expression as best we can first. So we have 3 s to the third t to the negative 2. All I have to do is move that variable with a negative exponent to the bottom of a fraction. 3s to the third over t squared. Substituting gives me 3. S is 2 over t is negative 3. Okay, so that's now 3 times 2 to the third is 8 over 3 times 3 is 9. And so my answer becomes 24 over 9, or 2 2/3. Okay, let's try some got it problems. So here's my values. N is negative 2, W is 5 for all of these expressions. Okay, now here's a nice little trick. If you see this, W to the 0 power, anything to the 0 power, even 5, anything to the 0 power just turns into a 1. So we are now going to be multiplying something, n to the negative fourth, times 1. And when we multiply something by 1, it stays the same. So what we can do is if we see something to the 0 power, we can just get rid of it because we're just going to be multiplying by 1 and it's not going to change the expression. Provided, of course, that there's no addition or subtraction in any of these things, which there's not. These are all one-term problems. Okay, so now that I got rid of that w to the 0 power, my expression looks like this, 1 over n to the positive 4 power, which then gives me 1 over negative 2 to the positive 4 power. And now all I have to do is raise 2 to the 4th power, or negative 2 to the 4th power. But a negative times a negative times a negative times a negative 4 times is going to give me a positive. So my answer is 1 over 16. And in fact, anytime we have a even exponent, a negative raised to an even exponent power, the negative will cancel out. Okay, let's try B. First step, move the negative exponent term to the bottom of the fraction. So that it leaves me nothing on the top. So I just put a 1, and we have n to the first power now, positive first power, so I can just leave it as n, w squared. So that's 1 over negative 2 times 5. So my answer becomes 1 over negative 10. Okay. For part C, that just goes away, and we have 1 over w to the 6th, which is 1 over 5 to the 6th. Going to be a big number, but that's okay. With my calculator, I can just get this as 15,625. And last, we have D. Move the negative exponent to the top, so it becomes w over n, which is 5 over negative 2, which not the best idea to leave with 5 as a positive, 2 as a negative, so that means that this fraction just becomes negative 5 over 2. It's kind of bad form to leave a negative floating around in the denominator like that. Could get confusing. We usually move it to the front of the fraction if the fraction is negative, which it is because we have a positive divided by a negative. So for part E, is it easier to evaluate n to the 0, w to the 0 for n equals negative 2 and w is equal 3 by simplifying first or substituting first? Well, like I said before, simplify first, and it's just going to be 1 because they're both to the 0 power. Okay, so if you substitute first, that's one extra step that you didn't have to do because everything's raised to the 0 power. So we know the answer is going to be 1. Let's try a word problem here. So using exponential expressions. So population growth. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h power, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h is equal to 0 and h is equal to 3, negative 3. What does each value of the expression represent? Okay, so here's my function, right? The variable is h, so we can say f of h is 1,000 times 2 to the h power. Okay, if we plug in 0, we get 1,000 times 2 to the 0 power. Anything to the 0 is 1, so that becomes 1,000 times 1, which is just 1,000. So that means that there was 1,000 bacteria present at 0 hours. So there was 1,000 bacteria when the experiments started, or when we started timing whatever, right? Or time 0, whatever that happens to be. Now, if we plug in a negative 3, let's do it first. Okay, so that's going to be f of negative 3 gives me 1,000 times 2 to the negative 3 power, which is 1,000 times 1 over 8. So it's basically 1,000 divided by 8, which is 125. So that means that if the hours equals negative 3, okay, and h is the number of hours after a scientist measured the value of the expression, or the value, or measured the size of the bacteria population, that means that 3 hours before that, or 3 hours ago, the population was 125. Okay, let's try got it problem. Population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the W power, where W is the number of weeks after the population was measured. Evaluate it for -2, 0, and 1. So, whoops, sorry about that. So, we're going to do W equals -2, W equals 0, and W equals 1. Right? So let's not write the whole function here. We have 5,400 times 3 to the -2, which is 5,400 times 1 over 9, which is 600. Okay. Let's just do them all real quick, and then we'll talk about what they mean. So this is 5,400 times 3 to the 0 power. 3 to the 0 power is just 1. So this is 5,400. And finally, this is 5,400 times 3 to the first power, which is 5,400 times 3, which gives me 16,200. Okay, so if W is equal to the number of weeks after the population was measured, this is when he measured the population. This is 2 weeks before that and 1 week after. Okay, so here's where your experiment is at its 0 time, or when the person actually measured the insect population. 2 weeks ago, 1 week ahead, 1 week forward. All right, so our lesson check here, right? 2 to the -5 power, that's going to be equal to 1 over 2 to the 5th, which is 1 over 32. Okay, m to the 0 power is equal to 1. This one is going to be 5. 5's and s's look the same. 5s squared over t. And for number 4, we're going to get 4x to the +3, right? This comes up to the top. All right. Evaluate each expression. So just plug in, simplify first. So this simplifies to a to the 3rd over b. This one simplifies to 2 over a to the 4th. The b to the 0 just goes away. And then just plug in 2 and -4 for a and for b. For 7, a positive exponent shows repeated multiplication. What repeated operation does a negative exponent show? Repeated division, we could kind of say, right? Or basically just repeated multiplication with a fraction, or repeat, same thing. A student incorrectly simplified a x to the n power over a to the -n b to the 0. So he said is undefined. What's the mistake? Is the mistake that this is not 0, that it is 1. So it is not undefined. Anything to the 0 power is 1. And that is 7-1, 0, and negative exponents.